today session 2 is forecasting of assets return. Both of the sessions will be taken by Dr. Miklesh Prasad Yadav. Now, I would like to introduce you to Dr. Miklesh Prasad Yadav. He is serving as a faculty at the Indian Institute of Foreign Trade, IIFT Kakinada. He has more than 14 years of consistent and proven record of teaching experience and contributed acclaimed publication of 66 research papers in ABDC, ABS, Web of Science, and Scopus Index journals, including 14 research papers in ABDC A category. He is also a guest editor of the International Journal of Public Sector Performance Management and the Journal of Content, Community, and Communication. Both of these journals are Scopus Index journals. Dr. Yadav has delivered lectures as a resource person in more than 175 workshops and FDPs conducted by premier business schools. Now, I would like to invite Dr. Miklesh Prasad Yadav to start with the session one.
Thank you.
Over to
Thank
you,
you
sir.
very much for the introduction. I hope I'm audible.
Yes, sir, you are audible.
Okay, thank you. So I hope, yeah, I have been given right to share my PPT. It's fine.
Sir, I have made you a co-host. You can share it. You can turn on your camera as well.
Yeah. I hope my PPT is visible to everyone, right? Is this visible?
Yes, sir, it is visible.
Okay, thank you. Okay, so good evening, one and all. I'll be just discussing in two different sessions related to financial
No,
analytics,
sir, it is not
including
visible.
forecasting.
Is it visible?
PPT is visible. I think PPT is visible, right? Yeah, Dr. Gaurav, is this visible? PPT. Mamta ma'am?
Yes, sir, it is visible, sir.
Okay, thank you. So in first session, I'll discuss about financial analytics, including the significance of financial analytics, and then we'll get acquainted with time series analysis, and then we understand about distribution pattern of assets return, including log return and sample return, and then we'll be having hands-on session using RStudio, right? And I request each and every participant to just have or download your data set. I have already shared to organizer, and organizer might have shared with you. In addition, I also shared the link to install R in RStudio, right? So moving further ahead, if I talk about the concept of financial analytics, it is nothing but simply it indicates analyzing large amount of financial data, predominantly historical facts and figures. It helps to companies to identify past trends and correlations to identify their business of financial status in terms of profitability, value, and cash flow. And with the help of this financial analytics, companies can rely on actual data rather than perception to build business strategies. Hence, financial analysis forms a vital part of any business. Look at it. If I interpret the crux of this slide, basically, financial data deals with historical, or financial analytics deals with historical data, historical facts. Now, the question is why? What is the need of that analysis of financial analytics? That is the question. For the same, there are certain significances like forecasting the series, tracks the financial performance, increases visibility, predictive analytics and planning, and then determining the risk. One by one, we'll be talking about these significances, right? So let me exemplify.
Sir, could you please turn on your camera?
I think if I turn on the camera, it will be a little bit difficult to just for the network. I think a little bit network
Oh,
issues.
okay.
Like, okay. So the first is forecasting the series. Look, as I mentioned that we'll generally financial analytics what it does, it forecasts the historical data as we have seen in first significances, right? One of the first or one of the significances is there. That is, we forecast the historical data. Look, actually, it says that whatever happened in past, it will be repeated, isn't it? It means this is the reason we look the trend of any particular return, whether it is related to Apple or might be any particular company. I'm not just uh, isolating it in terms of any company. Rather, we believe that based on the past performance, we may look at the future aspect. And this is the reason, and that can be understood, that can be analyzed with the help of financial analytics. For example, as you know that like any investor, investors always believe to make their future better than today. And that can be possible if they analyze the risk, if they forecast the return for the future, isn't it? And that can be done with the help of your financial analytics. And of course, in second session, we'll be talking about how to forecast, right? Second is track the financial performance because financial analytics is purely involved with the financial data. And because of that, it helps to analyze the track record of each and every year of be it in a form of individual company or a sector or might be the any particular country. It can definitely it help you to just keep the track record of your financial performance of the companies. It increases the visibility because when any company uses this financial analytics, it helps you to just make financial data visible. And with the help of that, might be the investor attract towards this and then they think for the investment. Then another thing is predictive analytics and planning, as I have already discussed, that is in terms of forecasting, right? And then determining the risk. Of course, based on historical data, you can easily identify the risk, right? Whether it is the risk is high or low or etc. Right? And based on that, one can invest. So these are the significances of financial analytics. Look, financial analytics can be incomplete with I mean, if you do not consider time series data, then right, because we analyze historical data in financial analytics, and time series is the data that considers that contains your historical data, right? So let's understand this time series, and then we understand after it we'll be able to understand the distributional pattern of time series. So if I say time series, it's nothing but a set of observation taken at specified times, usually at equal interval. And a time series is a set of statistical observation arranged in chronological order, and this is nothing but function of time. So y is nothing but function of time. Let me exemplify with the help of suitable example. As I mentioned that time series has an equal interval, right? For example, let's suppose Reliance Industry Limited share price, right? Day one, day two, day three, and day 3, and so on, day n. If I say Reliance Industry Limited is, I mean, one of the series, right? One of the series, and it might be having different day. It means day here, it means I'm talking about date. Might be 1st January 2025, 2nd January 2025, and so on. It should be at equal interval. There should not be like the there should not be like day, month, year in a one go. For example, we can't write here like day 3 and then we can't write here month 4. We can't write here year 5. Getting me? If your data is daily, then your entire observation has to be daily in nature. This is your time series data. Now the question is why? Why there should be equal interval? Because you are going to analyze with the help of financial analytics, you are going to forecast it, you are going to determine the risk. And it can be possible if you have the data, if you have the observation at equal interval, right? This is the reason there should not be, for example, let's suppose day one. Day one might be uh, 2900, right? After this, there might be 2910, might be 2980. After, if I write here month 4, there might be the huge differences. After 4 months, it might be devalued, it might be appreciated, isn't it? So it will be very difficult and it will be like wrong if you forecast considering this. Might be here 3,400 after 4 months, isn't it? Might be if company has not performed better, then it may be devalued also. So directly jumping from day 3 to month 4, and if you analyze any particular thing, I'm not talking about the risk or return, be it in form of financial track record or anything, then it will be providing you, it will be furnishing a vague result. And this is the reason we always believe that there should be equal interval in any time series data, right? So this is understanding about this slide. I request each and every participant, whenever you get doubt, you may put your doubt and organizer may just inform, yes, this is a doubt. And definitely I'll try my level best to uh, just answer the doubt or answer the query. Well, actually, any time series may have four types of like component. One is secular trend, then seasonal variation, cyclical variations, and irregular variation. Secular trend is nothing but it is related to the long-term trend. Long-term trend, like the best example is population growth of our country, right? So it has long-term trend. Seasonal variation. If you look at the sales of ice cream in during the summer, might be totally different from winter. So this seasonal variation includes in any particular series. Then cyclical variation, the growth like the share price or might be any particular trend in different cycle may differ. For example, the share price or the profit of any particular company which is in introduction phase might have different from the mature company or might be at the uh, I mean simply we can understand that every industry has cycle. It means business cycle we are talking about, right? Either it is in introduction phase or growth phase, mature phase, declining phase. So based on that, the share prices profitability may differ. Irregular variations, the best example irregular variations is might be earthquake, might be the natural outbreak like COVID-19, then these man-made outbreaks, Russian-Ukraine invasions, various kind of geopolitical issues, they might be irregular variations. It cannot like affect like the regular uh, effect. So these are the things which are included in any particular time series. And the best example you might have seen, the any a scandal happens in a company may drastically change the performance of that particular company, right? So these are the components included in your time series. This is all about the traditional concept of time series. But when you look at the modern concept of time series, it's totally different. And this is nothing but modern time series says it is realization of particular stochastic process. Again, I'm repeating, it is nothing but realization of particular stochastic process. And every realized observation of a stochastic process is understood as time series. Now, the question is, what does it mean, this stochastic process? That is the concern, and we have to understand it. What is the concept of your stochastic process? Look, everyone might have played Ludo, right? And when you play Ludo, generally everyone is thinking that, and everyone predicts कि when you throw a dice, you may get six, isn't it? Everyone is worried about it. Might be four, might be five, but no one knows that what will happen. You throw a dice, it may come either one, two, or one to six. In between, you may get any particular value, but you do not know that value. This is known as a stochastic process, right? It means you throw a dice and then it may get any value. So what does it mean, this stochastic process? By the way, stochastic process is nothing but any random variable whose value changes over a time in an uncertain way. And that is your stochastic process. For example, simply let me explain with the help of word file. Today, or might be yesterday, Reliance Industry Limited or any share price, day one. Let's suppose in day one, the price is 3,000 or 3,100. You can't say that in day two, it will be 3,110, or might be in day three, it will be 3,220, or any particular value. You can't say it. Value may change in an uncertain way. This is known as a stochastic process. So, in one sentence, if any value changes in uncertain way, that is known as a stochastic process. Look, the best example is a stock market. How? Let's suppose early in the morning, market opens at this particular point, whether Sensex, Nifty, right? And then after a certain period of time, it may come to this. After a certain period of time, it may touch this level, and then this, and then this. And finally, at the end of a day, might be 3:30, it will be your this point. To be precise, from 9:30 to 3:30. At 3:30, you might, 3:30 I'm indicating at the end of the closing of a stock market. This value, you have realized one value. You have realized one value with the help of this process. And this process is known as a stochastic process. Always remember there is a great role of this stochastic process. And later on we'll discuss from that particular process trend is introduced. That is in terms of a stochastic trend. Right. It means, to be precise, any value which is derived from a stochastic process is called time series. For example, the best example is a stock market. Another example, as I portray that, your dice. When you throw a dice, but value will be uncertain. You do not know. You do not know that it will come six or might be four or might be fifth. Getting it? But at least with the help of that uncertainty, you may get one value. That value is your realized value from a stochastic process. And the best example, as I said, this is your stock market. Early in the morning at 9:30, my the uh, I mean Nifty point or might be Sensex point will be different than this, and at last you get a value. So the entire process, entire steps which has combined at the end of this is known as your stochastic process. So to be precise, time series is nothing but realized value from those stochastic process. Right? I hope this is fine. This is crystal clear. In case of any doubt, as I requested, you may just put in chat also so that it may be uh, like great interacts. Coming to the point, features of time series data. Look, financial analytics, as I mentioned, that purely based on your time series or might be panel data, right? Since we are talking about the time series, so this time series may be related to their own past. The first thing, what does it mean, this on past? As I have already said, that why we lag behind historical data. Historical data has happened in past, but still we are lagging behind it. I mean, if you are going to invest in Reliance Industry Limited or might be in any particular TCS or might be any particular stock, you look at the trend of that particular stock. Why? What is the reason? Reason is it is related or it might be related to their own past. We consider that a past company has performed better, so it is linking into the future. It might be in near future, it will also represent in the similar way. It means, to be precise, time series data may be related to their own past. This is the understanding, right? And this is the reason we believe in investing those companies which are yielding a good return in past. Second, they may be subject to deterministic trends, seasonality, and cycles. I have already told you in last PPT, in last slide, that it is nothing but it is having deterministic trends, seasonality, and cycles. The best example of ice cream, sales of ice cream in summer, totally different from your winter ice cream sales. Third, in case of multivariate context, they may have cross correlation. It means, just let me exemplify it with the help of this. When you say you have sales, right, and you say sales is the function of advertisement, right? You say sales is the function of advertisement. It means if advertisement will increase, there might be possibility that your sales will also increase. Now, if I say sales of 2025 is the function of advertisement of 2025, if I say that will be totally wrong. Why? It does not mean, sorry, it does not mean that if you advertise in 2025, it will affect the sales of 2025 only. Again, I'm repeating. It is it is not necessary that if you if you spend more on advertisement in 2025, it does not only affect the sales of 2025. Rather, it may affect 2026, might be 2027, isn't it? It means this sales of 2025 might be the function of advertisement 2025, advertisement 2024, or might be so on at the past. It means they are having the cross correlation. Cross correlation. It means, it simply means that I have exemplified here that, for example, advertisement expenses for the month of January will affect the sales not only in the month of January, but may affect the sales of February and coming month. This is your cross correlation effect. And by the way, it just it occurs in case of your bivariate or might be multivariate time series, but does not in case of univariate time series. So these are the features of time series, and this is the reason we lag behind the historical data rather than your only the perception based data, right? Well, generally, when you look at financial analytics, we believe in two types of return. And I think the participants who are teaching investment management or who might have the idea related to finance, they might be knowing these two returns: simple return and log return. If I say simple return is nothing but simply the like PT minus 1. It means if I say the observation is daily in nature, PT indicates here today price minus yesterday price and upon yesterday price. Similarly, if I talk about log return, this is nothing but the log of PT and PT minus 1, right? It means simple return and log return. Now, question is which return is better? By the way, both return are in like hardly you may find a little bit differences into in between the simple return and log return. However, we believe in log return. Why? Because it is nothing but it is purely based on continuously compounded return. And in financial analytics, majority of the models, majority of the tests are being applied on log return. This is the reason we have to understand the pattern, distributional pattern of log return, and then we proceed for the forecasting. Even in next session, like after 7:30, we'll be talking about how to forecast that return. It means by default, if I say return, it means by default we are going to talk about log return, right? Because it is additive in nature and it is continuously compounded. So this is the formula how to compute this simple return and log return in RStudio, and definitely we'll be doing right now after just 2 to 3 minutes in RStudio how to compute it. So to be precise, in a nutshell, there is no as such much differences between simple return and log return. Number one. Number two, log return is continuously compounded return, which is additive in nature, whereas simple return is not. And of course, Now the question is, we started with prices, as I just portrayed, whatever example right now, till now, whether you talk about Reliance Industry Limited share price, might be share price, but suddenly we just jump on return. Why? Even you might have taught this share price or anything else. So rather than going for the share price, we directly talk about return. Why? What is the reason? Whether you talk about Nestle share price, which it's large compared to uh, penny stock, or might be the stock which is very less than 300 share price, might be 500 share price, but no one is worried about share price. Everyone is worried about return. Even penny stock, even a small cap stock, they give you the large return. So now the question is, no one talks about price, rather everyone talks about return. And whether the share price is less or high, it does not matter, but return has to be higher. This is the reason that we always work on asset return, then the price, and these are the reason. In financial analytics, if you look at it matters a lot. For average investors, return of an asset is a complete and unit free of invested amount. Look at it. It says unit free. Whether you have invested in Bitcoin, in dollar, or you invested in rupees in India, it does not matter. The matter is how much return you have generated. And the moment you talk about return, it converts into unit free. And this is the reason we work on asset return. Number one. Number two, it is very easier to handle than the price series. It means return series is easier to handle than compared to your price series, right? Why? Because in a same series, let's suppose in you are working on two series or might be three series. In one series, you will be working on Bitcoin. In another series, you will be working on share price, or in another might be you might be working on any index like Sensex or Nifty. We have three different value. Let's suppose, as I put an example, one is Bitcoin, might be your TCS share price, or might be Nifty. There are three different index. Might be one is related to your, as I mentioned, dollar, might be rupees, might be the points, Nifty in points. But here, if you convert into return, it will be very easier to identify that which has performed better, which has furnished the good return among your select assets class. Getting me? It means this is your return which helps you to identify. Otherwise, it will be very confusing that it is in dollar, it is in the price will be something different, the Nifty points is something different, right? This is the reason it is easier to handle. And then the third is return series are time additive in nature. When you look at the log return, it is additive in nature. It is compounding. The same thing is your return series is time additive in nature. It means we are talking about here compounding additive nature, right? So in this way, always remember we have to think from the return point of view, not the price point of view. Later on, we will be talking the stationarity of return, right? So till now, if anyone will ask, then our understanding will be like this. These are the reason. Because of that, we work on assets return rather than price Yeah, now I request each and every participant to open their RStudio because it is all about the practical session. So if you work simultaneously with the help of your hands-on session, that will be creating a crystal clear idea, right? So requesting each and every participant to open their RStudio. I hope participants have installed R in RStudio. Okay, I think it is being recorded also. So later on, even whosoever misses this, later on they can go through it also, right? Okay. Um, this is my R, right? This is my R studio. Okay. So it's even first time, let's suppose you open first time, you may get like this. When you open first time, you may get like this icon, right? And if you click here, this is your R Studio. I know that these days people are talking about open access software freely available. So R and Python are few of them. There are innumerable open access software these days, but R is one of them. Like the first one is R script. The first one is R script. Second one is this one, like where environment is empty is written here. This is your data object. And third one is like file, plot, and packages. So files, plot, and packages, name itself says. And then fourth one, file, plot, and packages. And fourth one is console. Here, like I'm writing here this. So this is console. It means there are four windows, right, in RStudio. Again, I'm repeating R script, then data object, then file, plot, and packages, and finally we have console. So from uploading the data to or from uploading the data to generate the result, each and everything will be generated in these five windows. In any particular analysis, whether we talk about forecasting of a series or computing the return, we require data. And for the same, I shared data few days back. So we are going to work on Mint file. I have shared you Excel file. So I'm going to upload that Mint file. How to upload the file? So simply go to this file. When you go to this file, there are innumerable options. Innumerable options, right? And out of that, there is import dataset, right? Out of that, I go to this file, then import dataset, and there are innumerable options. Out of these options, you may opt any one of them as per your requirement of data. This is one of the way. Another option is like here, there is import dataset. So you may also click here and then based on your requirement, you click and then you may just upload the data. So it's purely up to you. It's purely up to you whether you want to upload the data with the help of this file and or you may opt with the help of this. It's purely up to you. So Just I'm going to upload the data with the help of this option. I go to File, and then I click on Import Dataset, and out of that, I click on from Excel. Why Excel? Because the dataset which I have shared is in Excel. And then I click on Browse, and this is my data set, which is mint file. So I select this mint, and then I click on import. After clicking on import, my data is uploaded here. I hope everyone has done like this. Now, again, I'm repeating, what did I do? I just go to File and then Import Dataset, then click on Excel, and based on like nature, my data is Excel, in Excel. So I click on this Browse, and then I just select this Mint file and click on Import. Now, my data is available with me. I hope everyone has done like this. Dear participants, in case of any doubt, whosoever is doing, please let me know. And till now, any doubt in understanding what I have discussed, you may just drop a message in chat so that we can discuss. Okay, this is your data set in R. By the way, first let's understand what is all about this data set. This data set, this observation is daily in nature, like this 1, 4, 5, 6, 7, 8, and so on, daily in nature. And the name of this file is Mint file. Mint, by the way, Mint is a group of 4 countries: Mexico, then your Indonesia, Nigeria, and Turkey. And these are the stock exchanges of these particular companies. And later on, BSE is our Sensex data, right? So this is your data set. Now, what we are supposed to do when you are going to analyze any particular observation, any particular data in RStudio, first thing you are supposed to understand, and you are supposed to do, like, attach and then file name. If you write attach and file name, it means RStudio recalls, and then it is no need to just write separately, like Mexico JKSC with the help of dollar symbol, right? So better to write like attach and file name. Now you are ready to work on it. It will compute like descriptive statistic, because the first thing we are supposed to understand the pattern of any particular series, and that can happen with the help of graphical display, or might be the descriptive statistic. Only then you can compute the return, right? So if I write summary and then Mexico and enter, we get descriptive statistic of Mexican market. As I mentioned, that Mexico here is nothing but a stock market which is available in Mexico, right? Similarly, JKAC is the short form of market here of your Indonesia, right? So Mexico, it means descriptive statistic. If you want to do, if you want to get, then the command is something. What are these? What are these value here? If I say min, it means nothing but minimum value, then first quartile, median, mean, third quartile, and maximum value. So in this way, you can interpret that in Mexican market, the maximum observation is this, and minimum observation is this, right? So this is one of the ways to understand the pattern with the help of descriptive statistic, right? Look, If I want to know, let's suppose how many observations are there in Mexico. First and foremost, there are only five observations like Mexico, sorry, five variables, five series, Mexico, JKAC, NGAC, BEAST, and BSC. So it is visible. But let's suppose if you work on innumerable variables like 50, 60, it will be very difficult to identify. For that particular, we have like attributes command. So you write attributes and file name. File name is mint. So the moment you write attributes and mint and then you enter, you get this option. It means it says that in data set or in this data set, these are the variables name. And it's very easy command. And that is what attributes and then any particular file name. Right? Let's suppose I want to know that in Mexico or JKAC or NGAC, how many observations are there? So command is very easy, and that is length and then Mexico and enter. It means this Mexican market has this data. In this data, under this Mexican market, 1,990 observations are there. Right. So this is one of the ways to understand the pattern of your any particular series when you analyze the data. Now the question is why people shifted from other software to RStudio while analyzing any kind of data. As I mentioned that it's freely available and it gives a wonderful result. Even if you have large number of data, you can analyze it. Another question, the few participants might be having uh, the question, every time we are writing this command, like summary, if I forget then what happens? Always remember there is history. Let's suppose you do today and you want to do tomorrow. While doing any kind of analysis tomorrow, whatever you did in past, let's suppose you forget it. Simply you go to history and whatever you have done till now, everything is being recorded here. And then you can look at the command and then you can write. Like, for example, yes, for descriptive statistic, command is summary. So simply you write summary and then Mexico, you get it. You think, no, I do not want to write. So simply you select it and then do enter. Automatically it comes under console. You simply you select it and then press enter. You get the value in console. In this way, in this view, we can say that it's great to analyze the data and do not think. Actually, the thing is that majority of the participants may think, or generally, this is the general understanding that people think it's purely based on programming. No, it's not like that. Person from any domain can use this, right? Okay. Moving further ahead, as I mentioned, our purpose, when you talk about time series, our purpose is purely based on return, not the price. And these are your index. It means this is related to your price, not the return, right? And price is nothing but noisy. Price gives the noisy interpretation. So, question is how to convert this price into return, these points into return. Look, I write here summary or might be any command. Let's suppose length, right? Or might be attributes. These are nothing but these are inbuilt package. Now, there is a great role of package here, right? So we have to install the package. If I talk about package, one is your inbuilt, and then another one is additional. You have to edit. So these are your inbuilt package. Like I write summary, then you get it means base package, inbuilt, base the inbuilt, you have the base package, right? Now R is only one software, but you can analyze time series, you can analyze panel data, you can compute text analytics also. For the same, different packages are there. So packages here provide the extra support, right? For example, I want to analyze the time series data. I want to compute the log return, risk of this max score, JKAC, and so on. So this is related to time series data. For the same, we can install or we can just install the packages, and for the best uh, there are two packages which gives you the best result in case of time series. One is your T series. By the way, this T series is nothing but time series data, right? This T series is not of Gulshan Kumar, right? This is T series. And another one is TSSTDO. These two packages will be will be installing it, and then we proceed further ahead. Now the question is how to install package in RStudio, right? Here again we have two options for that. We'll be talking about by just clicking here, go to tools and click on your install package, the first one. Again, I'm repeating. So you can go to these tools, click on install packages, but always remember, in order to install package, you must have internet in your laptop or might be in your PC. Here, you can write T series and then click on install, right? Click on install. Within very fraction of time, within 2 to 3 seconds or maximum 5 seconds, you have got the package here, right? So what it says T series successfully unpacked and MD5 sub checked. It means it has been installed, right? Then we have installed this T series package, and again you go to this, and here you write TS Studio package and then click on install. So it says, do you want to restart? No. You click on no, and then again within few seconds it will be installed. So again it says it has been unpacked. It means your both packages have been installed. When you do financial, I mean, if you focus on financial analytics using RStudio, these two packages are of utmost importance. So, which packages we have done? Two packages. One is your T series package and another one is TS Studio. As I have already mentioned that this package is additional package. If you are going to analyze time series data, you are supposed to install these packages. If you analyze panel data, for panel data, there is another package. Now, after installation, you do not have to install again and again. Let's suppose you have installed today. It is not, or it does not mean that tomorrow again you have to install. Till the life of your RStudio, till the life of RStudio in your laptop or might be in your PC, it will remain there, right? But you have to recall it. So install the packages with the help of like go to tools and then click on install packages, and then right here automatically it will be installed. And then after installation of package, you are supposed to write like library and then T series, and then again library and TS Studio. Again, I'm repeating. What did I do? Library and P series, then library and TS Studio. So when you do library, always remember after installation of these packages, you are supposed to just write require or library. With the help of that, it starts functioning. Now your data is ready for the analysis of time series. I mean, R is ready to analyze the time series, right? So, as I mentioned, everything is computed with the help of return. And even out of that return, we believe in log return. So, how to compute? If you look at, as I mentioned here, log return is nothing but log return is nothing but diff. I mean, we write log and then pt upon pt minus 1. Meaning is today price upon yesterday price. And if you do the log of this, or if you look at, or if you look, if you just bifurcate it, you may come to know log of today minus log of yesterday, isn't it? P t minus 1, isn't it? It means, it means this is your computation. So whether you talk about this or this, both are the same. Log of, it means today share price log minus yesterday share price log, that is your this. It means log is nothing but diff and then log, diff log. Right? Log, it means this log and this log, it means difference log. So this is the command which is used in RStudio. And in this way, R is very smart. So we simply write here, I'm going to add like R Mexico and then equal to diff log and then Mexico. Again, I'm repeating. What does it mean? I just put R Mexico. So this, for my understanding, R, the moment I just read this R Mexico, it indicates that return on Mexico. It is not necessary that you can put only R Mexico. You can put as per your comfort level. Even you can put Ram Shyam, Ghanshyam, any particular. It means you are going to create the series. So anything you may write here, but this command has to be the same. It means diff, log, and series name. The moment you write like this, you have another series now, and that is in terms of R Mexico. R Mexico is nothing but return on Mexico, and this return is nothing but log return. Right? So now you have R Mexico, it means return on Mexico, and then you can analyze everything on the return Mexico. It means whether you compute descriptive statistics or you look at the pattern or you look at any particular thing, right? So this is your return on Mexico. It means return on Mexican market, right? Now, the question is, again, we can look at it with the help of like summary, R Mexico, and enter. So overall, if you look at the pattern, the minimum return is this, maximum return is this, and average return is this. Still, average return is your average return is positive. So approximately this is in point, and if you multiply by 100, that will be converted into percentage, isn't it? So this is your average return. right? If you convert into percentage, it will come approximately 0.0070 percentage, right? So this is the way through which you may compute it. Now the question is, if we have only understood the pattern in terms of like mean, median, max, but where is the standard deviation? Where is the kurtosis? Where is the skewness? These values are not given, right? And what does it depict? If I say the skewness of any stock return is high or low, how to interpret it? So again, we have to go for the another package. I'll just again I'll continue this, but before that, this is your value in terms of descriptive statistic. Now the question is how to understand or how to display the how to display graphically of any particular series. For example, let's suppose Mexican or JKSC or any particular series. For that, there is command ts underscore plot, and then you can write your file name. The moment you write like this, you get the graphical display. So I simply write ts underscore plot and then file name. This is my graphical display of entire series, right? So this is your best, and this color is represented by Mexican market, then Indonesian market, Nigerian market, and then your Turkey. And finally, this color is for BAC, it means Indian market. It means this is your graphical display of index. But I want to look at any particular return because, as I mentioned, return gives the clear picture about the financial, status, or you can say the financial performance of any particular company. So, how to compute the graphical display of return? So, you can do like this ts underscore plot and then data dot frame date data dot frame r mexico comma date and then -1 and then enter. If you write like this, if you write like this command, you get the graphical display of return. Look, what does it mean this command? Let's understand. The command is the same ts underscore plot. Here I put mint, it means file name. So entire observation has been just displayed graphically. But when you do the time series plot of only one return, like return on Mexican, so accordingly you may do return on JKSC and so on. For that, we have to write like this command. What does it mean, this command? It says data dot frame. It means we are going to combine data dot frame helps you to combine your series. So data dot frame and then return of Mexican market and date capital bracket -1. This command helps you to remove the first observation. This command, again I'm repeating, this command helps you to remove the first observation, right? So in this way, you can compute the graphical display or you can display graphically of any particular return, right? Now, let's understand about the distributional properties. And then again, we'll discuss with the help of RStudio. Okay. Normal distribution and log normal distribution. Though I think majority of the participants might be having this idea about normality, but if you look at the return pattern, it depicts huge differences. Look, a traditional assumption made in financial study is that the simple returns are independently and identically distributed as normal with fixed mean and variance. It says that when you look at the simple return is nothing but it follows IID, independently and identically distributed. What does it mean this? It says IID, it means independently and identically distribution is nothing but any series is independent, having the same probability pattern, having the same probability of occurring of any particular series, right? So when you look at the simple return, you may get your value is IID, but with fixed mean and variance. Coming to this log normal distribution, another commonly used assumption is that log returns, it means RT, of any assets are IID as normal with mean, mu, and variance. This standard deviation is square, and it is also known as asymmetrical distribution, fearing right skew. So here, to be precise, what it says, majority of the time, indicates that, to be precise, the crux of this slide is when you compute the simple return, there might be possibility that you may get normality. But here, the moment you talk about log normal distribution, there might be the asymmetry. Asymmetry here means like it won't follow normally distributed, right? It means asymmetrical. Asymmetrical here, there might be the huge chances of more gain or more loss, depending on whether the skewness is like less than or I mean negative or positive or so on. So this is your distributional properties of return. And in financial analytics, it plays a very, very pivotal role to understand the distributional properties of any particular return. Now the question is how to compute this skewness, curtaces, and other distributional properties, because this is the theoretical understanding about it, which I just explained now. Now we are going to do distributional, or we are going to check distributional properties of return on Mexican market in RStudio. Look, till now we have done two packages. One is T series, right? One is T series, and another one is TSTDU package. Third one we'll be talking about F basics. So go to these tools, click on this install packages, and right here F basics package, right? F basics package I have already installed. So in your case, you simply click on installed, and definitely within very few seconds, it will be installed, right? So right here, F basics, click on install, and quickly it will be installed. Like it is already installed here. So after after installation of this package, I have already told you that we have to write library and the package name, which is your F basics, right? So till now we have done three packages, F basics, and these three packages are of utmost importance in any kind of analysis related to financial data. So what I did, I have installed this F Basics and then I did library, F Basics, and then enter. Okay. After that, what we can do, we have to write here. Earlier we write only this. We wrote a summary and then R Mexico, right? But here it has not provided you skewness, courtesies, or any particular series. So what we can do? We write here basic states and then series name. Again, I'm repeating what I did. I just enlarge it. I simply write basic states and then series name. So with the help of this command, it has provided wonderful results. Wonderful result. Look at it. So many detailed understanding about the distributional pattern of return series. So let me explain one by one. NOBs, it is nothing but number of observation. So number of observations are 1989. This is NA. It means null value is 0. There is no null value. And minimum value is this, maximum value is this. This is your first quartile, third quartile, then mean, median, sum, and then this SE mean. It means a standard error mean. LCL. LCL means lower confidence level mean. UCL means upper confidence level mean. Then variance, standard deviation, skewness, and curtaceous. This is your distributional pattern of return, including skewness and curtaceous. Everything you know, because we have already studied in a statistic, might be in undergraduate or postgraduate, right? But this is the way to compute the pattern in RStudio. Now the question is, if being the financial analyst, I would like to analyze my return, and based on that analysis, I have to report my manager, or might be I have to suggest the client. So based on that, how to interpret, based on that, how to interpret like variance, standard deviation, skewness, and curtaceous. Look, here, this is the graphical display of log and normal return, right? So when you look at this log normal distribution, you may follow like this, which is asymmetrical, but normal distribution is this. Now, this is the distributional properties based on skewness and curtaceous. Look, positively skewed, it means long tail on the right side. This positively skewed return indicates that there will be small losses and few large gains. And in this distribution, mean is greater than median and then greater than mode. What does it mean? Actually, we compute, but the understanding is how you are expert in analyzing it. Everything is like the moment you write command, you get the result, but how to interpret, how to understand the distribution pattern so that you may suggest your client whether you have to invest into this or not. So the moment you find positively skewed, it indicates that there will be small losses, right? And few large gains. The just opposite, negatively skewed, it indicates that there will be frequent small gains and few large losses. So choice is yours. Whether you are risky player in terms of investment or you are risk averse investor, it's purely up to you. It says if your return is positively skewed, there will be small losses and few large gains. And this is the pattern like this. This is your positively skewed, this is your negatively skewed. And based on, like, if you think, yes, I believe in high return, I believe in high risk, accordingly, you may think. And then, as per your risk appetite, you may think for this. And this is the reason we say risk propensity should be in alignment with risk appetite. Right? How risky player you are in terms of investment. And this talks a lot. Right? Now, moving further ahead, we talk about stationarity. But before stationarity, again, now the question is, I want to compare. I want to compare which is much risky among these all five assets. I mean, all five return. So what you can do? You can, I have already computed RMAXCO. Then I compute the return on JKSE. So what is the command? RJKSE equal to diff log and then JKSE and then now I have return on Mexican market and then the return on JKSE, RJKSE. So two series I have now. One is one by one I can compute like basic states, then RJKSE, and then I write basic states R Mexico, and then I analyze, and then I compare. Yes, out of these, which is highly risky, which is having highly return. But it's a little bit time consuming. Of course, when you have two series, within few seconds you may compute. But let's suppose you have a large number of observation, right? So in this case, how can you analyze it? So it will be very difficult then. So is there any way to do this? Yes, there is. So simply in one go, you can compute and the command is like you may write basic states, then data dot frame. I have already told you that data dot frame helps you to combine the series. So I write here data dot frame, then R Mexico. This is one series. Another series is RJKC and then enter. The moment I write enter in one go, in a very suitable way, we have got the value. We have received the value. So this is the pattern, I mean descriptive statistic of R Mexico and then this is of RJKC. Meaning is return on Mexican market and this is your return of your Indonesian market, right? You may compare. You may compare the average return, right? And based on that, you may think which has a higher or lower return. And then similarly, you may have variance or might be standard deviation. Anyone can be used for the riskiness, right? So you may say, yes, return of this like RJKC is comparatively RJKC has high return than this, right? Then similarly, if you compute the standard deviation or your again it has the high standard deviation. So meaning is the interpretation is return on Indonesian market. Return on Indonesian market is having high return as well as high risk. So in this way, you can compute the all series whatever you have, right? And of course, when you just report this descriptive statistic in a research paper or might be anywhere, you can just do this. Now the question is how to get this result into Word file. Whatever you have done, this is in RStudio. How to get that? That is the question. So simply you select it. You select from here, select it, and you do right click and then copy and you paste wherever you want to paste. Anywhere you can, might be in your research paper or might be anywhere. I have just copied and pasted here. I have copied and pasted here. So you may just copy and paste anywhere, right? So this is about the understanding of distributional pattern, including your risk and return, right? Okay, coming to the point here, there is graphical display, right? And you have already understood that in this particular date, it is like a very long spike. It means this date contains a high risky nature of the market here. Similarly, here also much riskiness is found there. Okay, let's suppose I want to have this graphical display in my research paper. How to do? Very simple. We can just go to this export and click on copy to clipboard and then you click here copy plot and then you paste wherever you want. Now this is your graphical display, right? So in this way you can copy and paste in any particular series, right? So we have understood till now the concept of financial analytics with significance and your pattern. Again, if you look at the history till now, whatever you have done, everything is being mentioned. And this is the reason I again reiterate that it's wonderful software. Whatever you do, it is being recorded. And even when you do analysis tomorrow, you do today, right now, and then if you do tomorrow, it will be easier for you, right? So you may look at it and then you can analyze even tomorrow and whenever you want, you can do it. Okay, let me talk about another topic, and that is your stationarity. Okay, when you are going to analyze the data, analyze analysis of any data depends on objective. You want to analyze the data for whom and what is your objective. For example, my objective is to compute the risk and return pattern of all the stocks. So you compute descriptive statistic and then based on that you may suggest yes this is the market in which you may invest based on risk or based on return. But in addition, I want to forecast the series. Okay, I want to invest in our Mexican market. Should I invest into it? Whether it is predicted or it can be predicted positively or negatively, what is the predicted value? So based on that, you may decide for the future. Now the question is how to predict that. We'll discuss it, but before this prediction, what are the necessary steps? Right. So till now, we have whatever we are doing, these are the steps which have to be followed in order to forecast the series. And out of these important points, one of the points is stationarity. So let's understand this concept and then we analyze, then we check the stationarity of any series with the help of RStudio. So let me talk about stationarity. If I say return on Sensex or return on Nifty is having a stationarity, or you can say return on Mexican market is a stationary series. What does it mean? So a time series is said to be stationary if it has constant mean, constant variance, and remain the same no matter at what point we measure them. Therefore, a time series is invariant in nature. What does it mean this? What does it mean constant variance? Let's understand with the help of example. Here, let's suppose we have in my observation, in my data set, Mexican log return is there. So log return of Mexican, if you look at, we have 1989 observation. If you look at, how did I know? I simply write here len and then I write R Mexico. It means 1989 observation. When you divide into two parts, or might be four parts, or might be whatever equal parts, let's suppose we just divide into two parts, 1989 into two. So approximately half observation in one group and another, but here one observation will be larger. So approximately, if I write like sample one, right, and then sample two. So might be here, how much observations will be there? Of course, you can divide here also with the help of this, like 1989 divided by 2. We know, but I'm just showing, yes, we can just use like calculator also. R is very powerful into it. So approximately 994.5. So in one we may write 1994 and another one 995. It means if I divide into two parts, I write here 994 and 995, 995, isn't it? So now total number of observations is this. If the mean and variance of this group is near to mean of or variance of this group, then we say that my time series is a stationary series. So what does it mean? What is the crux? Crux is this, that a series can be said times a stationary series when it has constant mean, constant variance, and remain the same, no matter at what point we measure, but it should be your time invariant. So again, I would like to reiterate here that if you divide into two parts, and then your mean variance are constant, mean and variance of first group or first sample or first time period is just near to a second time period. Here I have mentioned sample one. It means first time series group and then another one is second time series group. That is called a stationary series. And there is a great role of time series. In financial analytics or in financial econometrics, the moment you talk about time series in nature, always remember it is having huge importance of stationarity. And whatever we apply to the test for the analysis purpose, without stationarity, it will be very difficult to determine that which test will be suitable for analysis. Right? So This is your one of the understanding about this. It means what are the characteristics of a stationary process? So these are the characteristic. Like it is mean reverting. Mean reverting means it is I mean just it will back to its own mean value, right? It means if my time series is stationary, this is the reason I said we have two groups. So mean is approximately mean of this group might be the mean of this. So this is the reason we mentioned that it is mean reverting process. Then it has a finite memory. What does it mean, this finite memory? Look, whether you talk about Great Recession in 1929 or you talk about global financial crisis, which happened in terms of Lehman Brothers in 2007-8, or you talk about natural outbreaks, which is COVID-19, if we collect the data and if my time series, if my that return series is not stationary, I mean, again, I'm repeating, if it is not stationary, it may have the memory for the longer period of time, infinite memory. But when my series is stationary, it may have the finite memory. Finite memory means here up to certain time, the memory is there. It means memory here means effect. Up to certain period of time, the memory may remain there, and after that, it may disappear. Getting me? For example, COVID-19. COVID-19 effect might be in any particular time series. After certain period of time, it may disappear if my time series is stationary there. If my time series is not stationary, it indicates that there might be the effect which is long lasting. So this is the interpretation of your this point. It means a stationary series has finite memory. Up to certain time period, it may recall and then it may die out, then it may disappear. And the same thing is mentioned in third point too. The impact of shock dies out with time. After a certain period of time, it may die out. And then we may analyze it. So these are the characteristics of a stationary process. Right? Here, I'd like to just request all the participants for 5 minutes break. Right? So I request organizer to just I hope 5 minutes break is fine, right?
Yes.
Okay. So yeah, ma'am.
Yeah. Dear participants, we can have 5 minutes break and we will join back in 5 minutes as sir has suggested. I hope you will all get back after 5 minutes on the same link.
Okay, thank you. Thank you, ma'am. Thanks a lot. Yeah. Hello, ma'am. Can you proceed now? I think 5 minutes is over.
Yes, sir. Yes, sir.
Okay, thank you. Okay. So before going to break, we discussed that these are the features of your stationary series, right? Now, moving further ahead, why stationary is important? What is the reason behind this stationarity? We have to understand it. Look, in econometrics, right, in basic econometrics by Gujarati, clearly mentioned that it states that the distinction between a stochastic process and its realization in time series data is just like the distinction between population and sample in cross-sectional data. Just as we use sample data to draw inferences about population, and in time series we use realization to draw references about the underlying stochastic process. And it is said that future will be like the past, which is an important one in time series. And if the future is like the past, then historical relationship can be used to forecast the future. But for that, time series has to be stationary. So the crux of this slide, it says that you you say the future is like the past. If the future is like the past, then of course historical relationship can be used for the forecasting purpose, but it can be feasible, it can be possible if your series is stationary. Here, if your series is stationary means constant mean and constant variance, and you know how to compute mean, how to compute variance, everything is now you are aware with, because we have just understood how to compute it. So why it is important? Because it important because of at least two reasons. The first, if a time series is non-stationary, we can study its behavior only for the time period under the consideration. As a result, it is not possible to generalize it to other time periods. And therefore, the purpose of forecasting or policy analysis, such non-stationary time series may be of little practical value. So, how to interpret it? Let's understand with the help of that particular data. You have data, daily data, right? Might be return data from 2020 to 2024, right? Daily observation. Let's suppose you have from 1st January 2020 to 1st January 2024. Now, if that data is non-stationary, non-stationary means it does not have constant mean and constant variance. So you cannot generalize. You cannot generalize. You cannot generalize means though that is historical data, but if you predict, the prediction will be not like generalizable. You can't say that in near future the prediction will be this. No, it can be possible if your data is stationary. Then it means if my data is stationary, if the data is stationary, then you can generalize out of the period. It means you can generalize beyond 2024 and then you can predict for 2025. Why? Because this data is having the stationarity. The same thing is mentioned here. Meaning is, it clearly mentioned that it is not possible to generalize it to other time period if that data is non-stationary data. So the crux is for the generalizability of beyond the period, your series must be stationary. Second, if you have two or more than two series, I mean bivariate or multivariate. For example, as I put the example, I exemplified with the help of sales and advertisement. If these two series are non-stationary, then it may give you the spurious regression, or that is also known as nonsense regression. It means spurious here means no use. Though you may get huge R squared, huge explanation of dependent variable by independent variable, but you cannot get the like good result. It means there might be spuriousness in your outcome. This is the reason while applying the regression for the analysis purpose for the time series, one may ask you whether your series is stationary or not. Have you checked the stationarity of your series? But the same is not available in case of cross-sectional data. There is no as such requirement of stationarity. Right. So the crux is number one, to generalize the result other than your considered period, and the second is to remove the spuriousness in the data. Time series must be stationary. Right? These are the significances of your stationarity. Now, a stationary time series is important because it helps to generalize it other time period due to which forecasting may be possible. And other reason is that it does not allow spurious or nonsense regression. Right. So this is your understanding about the concept. Okay. Now moving further ahead, how to check the stationarity? Because that is the theoretical understanding about it. But practically, you have to be ensured whether your series is stationary or not. So, how to check it? There are innumerable tests. Out of that, one of them is your ADF dot test, augmented Dickey Fuller test. So simply, you have augmented Dickey Fuller test, and the full form is ADF. I have written here ADF dot test and then series name. So what is my series name? Series is might be R Mexico or other series. So I simply write R Mexico and then enter. The moment I write ADF dot test and then R Mexico, right, it gives this result. My p value is 0.01. What does it mean, this 0.01? And we all know in social science, we work on, for the analysis purpose, we work on 5% significance level. What is my null hypothesis? Null hypothesis is return on Mexican market is non-stationary. This is my null hypothesis. Right? It means return on Mexican market is non-stationary. My p value is less than 5%. It means here my p value is less than 0.05, 0.05. It indicates what? It indicates that null hypothesis is rejected. When you say null hypothesis is rejected, what does it mean? It means my series is stationary. Return on Mexican market is stationary because my p value is less than 5%. And I may forecast it. I may predict it because my series is stationary. But if I write like this ATF dot test and then I write R Mexico, I get this result. But when I write like ATF dot test and Mexico, then I get this result. Look, this is my R Mexican. R Mexico is return on Mexican market, and Mexican market is your like point. It means the value is not in percentage. The value is not in return. Value is not in return. It's like a Sensex. It means it is like in point, isn't it? My p value is 0.31. When my p value is 0.31, what does it mean? It means my null hypothesis fails to reject. So p value is greater than 0.05. In this case, null hypothesis fails to reject. It is failed to reject. It indicates that price series rarely becomes stationary. Always remember a stock price or might be index cannot be, majority of the time, cannot be stationary. It may have non-stationarity, but when you compute the return, majority of the time you may find a return would be your stationary series. This is the reason we work on a return series because a return series gives you stationarity, and because of that we may generalize then other period, right? So this is about our understanding of testing the stationarity along with the concept. Similarly, we have another test also, and that is Phillips and parent test. Another one is ATF test, and then I simply write here PP test, PP dot test, and write R Mexico, and then enter. So this is your Phillips and parent test. Right, Phillips and parent test. This is the reason this is very famous in terms of PP dot test. Right? So till now we have understood three packages, that is T series, TS Studio, F basics, and we have understood two different tests to check the stationarity in any particular series. One is augmented Dickey-Fuller test and another one is Phillips-Perret test. Both gives the same result. There is no as such any kind of contradiction that ADF will give you the different result and PP test will give you the different result. There is no as such any contradiction. Moving further ahead, majority of the time, participants ask that how to check normality of any time series data in RStudio, right? So there is also a test, Jarke Vera. So you simply write Jarke dot, automatically it comes like this, Jarke dot Vera dot test, and you write series name and then enter, right? I'll interpret it, but even you do with the help of historical representation also, histogram. For example, I write HIST, hist, and then I write series name. This is the histogram, and it clearly indicates that it seems it is not normally distributed, isn't it? This it is not normally distributed, and with the help of that, you may just check with the help of p-value of test. So histogram says there might be possibility that return on Mexico is not normally distributed. For the clarity, we can apply Jarkibira test and command is this. So how to interpret? We can interpret with the help of like this. So what is my null hypothesis? Null hypothesis is return on Mexico or Mexican market is normally distributed. This is my null hypothesis. Return on return on Mexican market is normally distributed. My p-value, if you look at this p-value is less than 5%. It is the value is exponential, right? So when you get like exponential with minus, it means the p-value is less than 5%, right? Again, I'm repeating, when you look at any kind of like exponential and minus any value is there, it means we're talking about exponential value. And because of that, your null hypothesis is rejected. And then we say return on Mexican market is not normally distributed. And history is witness that majority of the series in return series you may check also that you cannot find normality in return series. Always remember, hardly you may find. And of course, I'm not saying that you can't find, but very rarely chance is there that you may find normality. Till now, I have found a very less, and this is fact. Return is not normally distributed. What does it mean? It means that like we are not getting the average return. Return is skewed due to certain events. There might be more fluctuation. Normality, what does it mean? Normality here simply is nothing but the value which is near to your average value. Majority of the values which are near to your average value, mean value, it means that is normal distribution. But market is purely backed by information. Market is information process as per the availability of stock, as per the availability of information, market reacts. And accordingly, you may notice that market is not normally distributed because of such type of events, because of such type of shocks which appear in market, and accordingly it reacts in terms of share prices. Right? If our Honorable Prime Minister Narendra Modi goes somewhere in other country, he speaks something about our India, ki India is growing or something like that. Its reaction is just visible in terms of the prices or the positive prices of a stock market. It means it becomes very difficult to find normality in the market. Okay, so with the help of that test, you may check normality. So till now, we have understood three packages, T series, T studio, and F basics. Now coming to the another important topic, and that is the forecasting. But sometimes participants ask that can we do like a density plot of this histogram? Yes, you can. And that is with the help of your another package R companion, and with the help of this plot histogram, and then you write your series name. What I mention here, yeah, I must write here. We are going to talk about another package that is R companion, right? This is your another package R companion, and you know how to install this. Simply you go to tools, right? You click on install and you write R companion, right? Everything is in a small letter, and then you click on install. I have already installed, so I'm not installing it. After installation of this R companion, you are supposed to write library and R companion, and then you may write like this command: plot normal histogram, and you get like this. So it is clearly mentioned that it is slightly different from normality. And you may normal density also. Plot normal density, and then you write R Mexico, and you get like this. It gives you the exact understanding that why it is not normally distributed. This is your the shape for the normality, but the true shape is this. So on this note, you can say that return on Mexican market is not normally distributed. And the command is plot normal density. Then another one is plot normal histogram. Right? I hope this is fine, dear participant. Okay, moving further ahead, let's say my purpose is beyond computation of risk and return to forecast return on Mexican market, or might be return of Mexican market. If my purpose is this to forecast the return on Mexican market, or might be uh, to forecast the return of Mexican market, how to do? Look, let's understand with the help of this. Yt is nothing but alpha plus beta, and then yt minus 1 and plus et. If I say this equation, it clearly indicates that this is known as AR1. Let's elaborate it. If I say YT is your series, it means any series. I'm not talking about only Mexican market. It can be Indian market, it can be GDP, it can be any particular series. It says today price of return is dependent on study price. Here, YT is today price. If my price is in daily nature, so YT is today price YT minus 1. It means study price. We are saying that today price is purely affected by study price. It means if study, if market faced positive return today also, it may repeat. It means study was positive, any particular return, then today it will be also positive. Why? Because it is your AR1. Auto-regressive, this is known as auto-regressive one. AR here is nothing but auto-regressive. Right? This is your auto-regression. In the same equation, if I add P1, now I just change it. I say P2, it means beta 2, YT minus 2 plus ET. What does it mean? Now my understanding is something different. What I say, today price is affected by yesterday price. I mean, I'm talking about be it any particular stationary series, might be today return or any particular series. So let me uh, just again mention here, this YT is return series. So today return is affected by yesterday return and the day before yesterday return. It means lag is 2. Here I use the standard terminology lag. Lag means past of series. This is known as AR2. It means the number of lag increases, the number of AR order increases. This is your auto regression. By the way, why I'm talking about this thing? My purpose is this, to forecast the return of Mexican market or might be to forecast the any particular series, right? So for that particular purpose you are talking about. But in reality, it does not happen like this. You can't say, if today market furnished, if market yielded positive return today, it may also furnish the positive return tomorrow. No, it is not like that. So what does it mean? The another concept I'm adding here in the same, if I say, if I say B1 is your ET, here I write ET. And then what does it mean? If I write like this, it means this is known as MA and then MA1. So what does it mean this? What does it mean this MA1? It says, today return is affected by ET minus 1. Here, what does it mean ET? ET is nothing but error term. So error term, we all know that error term is nothing but, to be precise, in simple language, in simple sentence, we say uncaptured portion. If anything which is not captured by this, it can be like uncaptured portion. Meaning is, if I say like this, it indicates that today price is affected by like uncaptured portion. It means today price, today return is not affected by its own past. Rather, there might be certain information which you don't know. It means error term is the same thing we're talking about uncaptured portion. It means we don't know that what are the information, but today return is affected by the lag of that information, which is known as moving average. And in financial analytics, it's really this is one of the very, very pivotal models, right? So MA1. Now, if I add in the same, like I add this and I mention like this ET minus 2, meaning is here it is your MA2. So today return is affected by lag of error term of yesterday and then lag of error term of 2 days back. This is known as MA2. It means moving average. This concept is known as moving average. So you have autoregressive, you have moving average. But in reality, it's very difficult to find pure AR and pure moving average. So what will be the equation? Equation might be that you may have the combination of that. So I write here like this. And now this will be considered as your AR1 and MA1. How? This is the terminology which we say ARMA. It means we have combined here. We have combined autoregressive and then moving average. That becomes my ARMA. And we say AR1, MA1. And when you combine this AR1, MA1, we write ARMA 1, comma 1. Try to understand this equation. If we understand this equation, definitely within very quick period of time, we can compute with the help of RStudio. But this is underlying understanding which has to be crystal clear. So if I recall yt minus 1, it means we are saying that today return is affected by yesterday return, right? Yt minus 1. And in addition of yesterday return, there might be certain information which we don't know. And of course, this is the reason we say, let's suppose market ended yesterday at any particular point, let's say 75,000 or 76,000. So it may continue from the same point today. It means there might be possibility that today price, today return might be affected by yesterday return. In addition, there is certain information, but we don't know that information. So that is captured with the help of error term. And by the way, this is very famous model which we call autoregressive and moving average, ARMA. Autoregressive and moving average, which is known as ARMA. And the order of this AR and MA depends on this your yt minus 1 and then this error term. It purely depends on it. And the same equation, if I add like this, if I add like this, if I add like this, like beta 3, and then I write et minus 2. So my order will be different. I have AR 1 and then I have error term 2. It means et minus 1, et minus 2. So my order will be like 1, comma 2. Why 1, comma 2? Because moving average is of 2 lakhs, whereas autoregressive is of only 1 lakh. And accordingly, we may change the like model. Now the question is how this AR and MA is decided. That is the question. How? How AR and MA are being decided. There is long history of it, but to be precise, if I say AR and MA are being decided by its your function, and the functions are your correlation functions. It means we say autocorrelation functions and partial autocorrelation functions. But in RStudio, there is a command, but the moment you write that command, it may give you that in this return, in order to forecast that particular return, the order can be easily generated, right? So let's forecast the series and with the help of ARMA. This ARMA is very famous in terms of Box Jenkins model or Box Jenkins methodology. Both are the same. Either we say ARMA or we say Box Jenkins methodology. Both are the same. And this is a methodology which is help to predict or forecast any series, but series must be stationary. So last package for today, and that is forecast. Till now we have understood 4 packages. The last package for today is forecast package. And by the way, it's very easy to just recall these packages because we are going to forecast. So the package name is forecast. We are going to analyze the time series data. The package is T series, and similarly TS Studio and so on. How to install the package? Of course, go to tools, click on install packages, and then you may write here forecast, and then click on enter. Now forecast package has been installed. So as I mentioned, after installation of package, we are supposed to write library and then forecast. Either you write library or require, but you have to at least you have to write one uh, package. Now RStudio is ready to apply forecasting model like ARIMA. In order to forecast, what steps you have to follow? So I'm writing here steps. Number one, data must be stationary. It means data here means I'm talking about series. It means any series, whether it is return series, GDP, or any particular series. We all know how to check stationarity. This is the reason everything is just chronologically ordered. So, how to check? We applied two different tests. One is ADM, another one is Phillips parent. With the help of these two tests, you can easily check. And I have already checked that Mexican series is a stationary series. Again, I repeat it. ADF.test, R Mexico, and then I have noticed that p value is 0.01. So null hypothesis is rejected. And we say that my series is stationary. So this is my stationary series. And of course, the first step is fulfilled. Right? Now the question is, what happens if my series is not non-stationary? Always remember, when you have sufficient number of observations, specifically return observation, then definitely you may get your return series stationary. But if you do not have sufficient number of observations, there might be possibility that you may not get a stationary series. So in that case, you have to do differencing, and then you may get it. Until and unless you do, until and unless you get difference like a stationary in series, you have to continue with that differencing. And the command is very simple: diff series. Simply write diff and then any particular series. But in my case, series is a stationary, so no need to convert into difference again, differencing series. No. Then second step is to know the order of AR. It means autoregressive and moving average. Look, I just exemplify here in terms of AR2, MA2, might be AR1, MA3, and so on. So, how to know that? How to know that in my data, if I'm going to predict, if I'm going to forecast the series, what would be the order of autoregressive and moving average? We don't know. We don't know this. So, for that, we have to write auto.arima. Again, I'm repeating auto.arima, and then I write rmexco and enter. This is the outcome derived from auto.arima. It means it says arima 301, right? But this is the result of your auto.arima. At the back end of software, what it does at the back end of software, actually moving average is related to your it is related to your PACF, and moving average, this is related to your ACM. It means autocorrelation function. This is your autocorrelation function, and this is your partial autocorrelation function. At the back end of software, it computes ACF and PACF, and accordingly, it gives you the order. And here we have seen this. It says ARIMA 301. It means autoregressive 3, MA 1. Till now, I was talking about ARMA, ARMA. But here, when you apply this, it is giving you ARIMA. What does it mean, this I here? You know, but what does it mean I? This I integrated means integrated, which is your I. So, so this indicates that whether your series is stationary at level or first difference or second difference and so on. So this integrated order here indicates the stationarity order, whether your series is stationary at level or one first differencing or so on. So by default it says O, right? It means autoregressive is 3, I is 0, and MA is 1. Meaning is we are going to predict the return on Mexican with the help of this order. AR3, it means today return is affected by last 3 days of return. And in addition, moving average by last one order, last one lag. And this series is stationary at level. It means 0. So 0 indicates here at level. And of course, R Mexico, we are working on R Mexico. We are not working on Mexico. We are working on R Mexico. It means stationary at level. So in this way, we can identify the order. So what is the order? Order is in my data. This order is your AR3 and MA1. Right. It means we are going to predict, we are going to forecast the return of Mexican market with the help of these lags. Right? After knowing these steps, after knowing the orders, what we can do, last phase or last step is to apply ARIMA. We can apply ARIMA and then we can go for the diagnostic testing. But how to apply ARIMA? Look at it. So I just are going to say in the value of X. Simply I write here X equal to ARIMA, right? And then I write ARIMA, then I write series name. What is my series name? R Mexico, comma, order equal to C 3, 0, 1. And then enter. What does it mean this? Look at it. ARIMA, it means autoregressive integrated moving average, which we have understood. This is my, after writing this command, you have to write the series name, like we are going to predict R Mexico. That's why I mentioned R Mexico. In your case, if you are going to predict any other series, accordingly, you may put that particular series name. And then we write order equal to C 3,01. It means we are going to combine it. Yes, order for the prediction is 3 lakh of that particular series. It means R Mexican. So R Mexican is predicted by last 3 lakhs, and then one order of moving average, which you have understood with the help of this auto.arima command. So the moment you wrote auto.arima and then series name, we understood yes, order is 3, comma 0, comma 1. And now this is my, it means ARIMA result. And the moment I write like X and then enter, I get the result of my forecasted. It means these are the coefficients. These are the coefficients of my different order. AR1, AR2, AR3, and MA1. From where it has come? It has come with the help of this command. It says, how to interpret this? It says, today return is affected by yesterday return positively because coefficient is positive. Today return is affected by yesterday return positively, whereas 2 days back negatively, 3 days back negatively. And even with the help of uncaptured portion, which is so-called moving average, it is being affected by negatively. And this is my intercept. So, if I write the equation of this, what will be my equation? Here, equation will be like this. Your YT, it will be 2. Then again 3 plus beta 4, right? And then ET minus 1. This will be my ARIMA 3, comma 0, comma 1, right? This is my ARIMA. It means AR3 integrated at 0 and moving average 1. Now, if I write like this, R Mexico forecasted, it means forecasting of R Mexico. This will be my alpha. It means this alpha is nothing but intercept, isn't it? From this result, it is my intercept, isn't it? Exponential value of 0.4 here. It means, and even there is in RStudio, you can get the exact value. You may convert it exact value. There is certain command, and the command is like, let's suppose I want to convert into the exact value rather than exponential. Can I do it? Yes, you can. How you can do? Like I write here options and then escapen and then 999 and enter. This is wonderful command in RStudio to convert exponential value into actual value. So I write options escapen equal to 999, and then when I write like this, now you have got exact value. Like earlier it was exponential value. Now we have the actual figure. Exponential has been removed, right? So what is your equation value here? I mean, I'm just putting these entire coefficients in equation. So I write here alpha is this plus your AR1 is this So I just copy and then I'm going to paste here. And then I write R Mexico, R Mexico T minus 1. It means T minus 1. And then it is minus. If I write T minus 1, it simply indicates that we're talking about AR1, right? And here it is in minus. So automatically your positive will be converted into negative sign. So AR2 will be like this. And then it will be your R max co T minus 2, right? And then again, it is the coefficient is in minus, right? So just let me copy and paste here. And then last one is your, so again, R max co T minus 3. And then it is again, your moving average is in minus. So the value is this moving average, right? And then I write this ET minus 1, ET minus 1. So this is your equation. This is your equation of forecasting. It means with the help of that, you can forecast your future Mexican return, right? Now, should you write this equation? No. Here, only I just interpreted for your understanding. It is command. So command will help you to forecast. The moment you write a command, you get the return, forecasted return, right? Only just, I simply shown you with the help of this coefficient, right? Now, what is the command of that? I simply just like I have shown here that this is the your coefficient, and with the help of that you have noticed the today return is affected positively by yesterday, but your rest are negatively affected. Now, what is the command of forecasting? Look at it. So simply I write forecast and then X. Why I'm writing X? Because I have saved the ARIMA value of like in X. So I write here X and then comma, I write 2 and then enter. Look at it. What I have written? I have written line 2. This is my forecasted. Instead of this 2, what does it mean this 2? This 2 says I have forecasted the return of Mexican market for next 2 days. This 1990, what does it mean? It is nothing. Recall how many observations are there in your series? We have 1989 observations in Mexican return. So after 19, R is very powerful in this regard. Automatically it has considered that based on 1989 return series observations, your next series is your 1990, and the return will be this. This is your forecasted return, one forecast. This is your forecasted return. Sir, can you compute for 10 days, 5 days? Yes, we can. So again, I'm writing here like forecast and then X, comma, 10 and then enter. What does it mean this 10? It means we are going to predict for next 10 days, right? So the moment you write this, you get the forecasted value. And if you look at after 1989, it starts from 90, 91, and so on. And this is your all about the forecasting. Meaning is, after 1989 observation, the next observation will be in negative. And after 2 days, again it will be negative, and then it will be positive. Based on that, based on the analysis of this financial data, you can suggest your client or you may think. And the interpretation is very huge. For example, I want to invest in Mexican market. I will be waiting for this period. Next 2 days will be, let's suppose, based on that, we may wait. Yes, in next 2 days, the Mexican market may give the negative return. So just wait. And after that, you may think for the investment because during that particular time, after 2 days, the market may give you the positive return. So in this way, this financial analytics helps you to forecast, right? And accordingly, you may decide. And as I mentioned, again, I'd like to just reiterate it. Risk propensity should be in alignment with risk appetite. Might be, I may be the risk averse investor, but you might not. So in this regard, you may just forecast and accordingly you may think for the investment. And this is wonderful command for the investing, for the forecasting of any particular series, be it in terms of your return series or GDP or any particular series. But remember, your series has to be stationary, right? After that, you may follow the next step, and that is for the diagnostic check. By the way, this diagnostic, when you are writing a paper, might be for that particular purpose, you may show the diagnostic check, but diagnostic check is optional. However, in terms of suggesting, you can interpret, let's suppose you are going to suggest any client, so you can interpret it, but it is optional. Again, I'm repeating, it is optional. So how to, yeah, one thing more. Let's suppose I have forecasted for next observation, right? So how to check it, right? So simply I write residuals, or we may write, you may compute the residuals of any particular series also, right? So let me auto plot and then forecast x comma 10 and then enter. Look at it. Here, up to this period, if you look at up to this period, it is actual figure. Look at it. But the value which is given, which is just displayed in this color, this is your forecasted 10 observations, right? So what is the command? Command is your auto plot forecast, right? So this is the command, and with the help of that, you can check the graphical display of forecasted. Then, as I mentioned, next step is your diagnostic check. With the help of that diagnostic check, you can see whether your forecasted is fine or not. So you may do check residuals, and then you may write like your forecasted value. The moment I write this, like check residuals and x is nothing but your ARIMA. So look at it. We have got different kind of plot. And when you just report this thing in your research paper, might be in your thesis, that will be highly appreciated. So this is all about your residuals checking. Like the first thing is whether the this is mean of residual is 0 or not. This is understood with the help of first plot. Again, I'm repeating from the first display or from the first plot, you may be able to identify whether it has like the mean of residual is 0 or not. Second is your ACF, autocorrelation function. If you remember, autocorrelation function, I have already told you ACF and PACF. It means autocorrelation functions and partial autocorrelation function. So these autocorrelation functions, we know autocorrelation, it means degree of associationship, degree of relationship of the same variable with its own past, with its own life. So that can be depicted with the help of this graphical display. And the third one is residuals. So this is the plot of residual. It means plot of error term, right? So in this way, we can forecast and we can report it, and then you may think for the investment or might be as per the purpose of users, right? Now, we have understood one thing that let's suppose I mention uh, I mentioned like this X like this. So you have AR1, AR2, AR3, MA1. But don't you think that this is regression? Of course. By the way, whatever you do, this is nothing but regression. This is the reason we say ARIMA is nothing but mean model. Again, I'm repeating. Because if you recall the regression, what it does? Y is the function of X, isn't it? Y is the function of X. In regression, it does the same. The same thing we were talking about. So by the way, ARIMA is the mean model. And we also say that it is average model. So by the way, whatever you do, whatever you forecast, you get the average value, right? Whatever you forecast, you get the average value based on this equation, based on these coefficients, right? Now, out of these four, like AR1, AR2, AR3, and MA1, how many of these coefficients are significant? So that will be the last topic now. So easily we can identify whether this AR1 is significant, AR2 is significant, AR3 is significant, or which one is not significant. How to know? For that, last package, though I have already discussed this thing, this should be the last, but no issue. Last package is LM test. So LM test here is linear model test. And by the way, when you talk about linear model test, it means we are talking about regression, right? So for which purpose we are going to apply this package? We are going to apply this LM test model here. It means LM test package here to know how many of these coefficients are significant, whether any one of it is significant or not. So let's install this LM test package, right? I just install this LM test package, right? And then I simply write, after installation of this package, I write this library and LM test, and then after installation of LM test package, the command is COEFT, coef test. Coef test means coefficient. COEF here means it means coefficient test, and then I write X, and then look at it. It's wonderful result. So what I write? Coef test and X, Look at it. These all are my coefficient here. It means this is my coefficient, this is my coefficient, and so on. Right? Out of that, wherever you find 3 star like this, it means they are significant. They are significant. So it indicates that AR AR1 AR1 is also significant, right? AR3 is also significant, and MA1 is also significant. This one. It is only AR2. It is only AR2 which is not significant. It is only AR2 which is not significant. It means in this way you can check the forecasting coefficient whether they are significant or not. So to be precise, if I explain since the beginning of the session, we have understood so many things related to financial analytics, including forecasting and your distributional pattern and significances. Still, I'm here. If you have any doubt, feel free to ask. From my end, the session is over. Yeah, dear organizer. Yeah, still I'm here. In case of any doubt, feel free to just put your doubt in chat. If you have them. Okay, so the one question is, if the AR2 is not significant, shall we remove it? No, it is no need to remove. There is no need to remove. Why? Because with the help of, there is logic behind it. With the help of auto.arima, if you recall, with the help of that auto.arima, we have understood that there are like certain lags. So we cannot remove now. It is not significant, a different thing. But it does not mean that we can remove, right? Yeah. Yeah, any other query? And it's great to see the query. If not significant, really that will be help us to predict properly. Why not? Of course. This is a kind of regression. Recall when you apply multiple regression or any kind of regression and you have, let's suppose, uh, 5 independent variables, and out of 5 independent variables, 4 are significant and 1 is not significant. It does not mean that you can remove that 5 one. Getting me? It is, of course, it is affecting it's different thing that it is not affecting significantly, but it is affecting. Getting me? So this is the way that we can interpret like this. Yeah. Okay, ma'am. Over to you. That's all from my end, and it's really good to see the participants' patience here. So thank you very much for your patience, dear participants. Yeah, Mamta ma'am, over to you.
Yes, sir. Uh, I think no more questions from the participant side. Yeah. All right. Thank you so much, sir, for such an insightful session on financial analytics using RStudio. I think the way you have demonstrated it with some hands-on practical examples on leveraging RStudio for financial analysis problems. You have made both the sessions insightful and enriching. that ways. Thank you for your time and effort, sir.
Thank you, ma'am. Thank you.
Uh,
So,
question
may I
there.
log out?
So there is a question from one of the participant. I'll just unmute him. Okay. He wants to know a book to read. If you can suggest some book to read.
There are innumerable books on it, right? But of course, from the basic level, better to go for the your econometrics by Damodar Gujarati. But there is a book of financial econometrics also. In that financial econometrics, everything is very given in a very crystal clear way. So the book, I'll just do one thing, ma'am. I'll send you the details of book because it will be very. It is Tise, the famous writer of that Tise. But full title I'll send you, so you may forward also.
Sure, I'll share with them in WhatsApp group. And for econometrics, Damodar Gujarati is a very good book. Even we have been referring that book. Okay, right. Thank you so much, sir. And dear participants, we have already shared the feedback form as well as the attendance form for the day. And apart from that, Drive link in which all the PPTs and other content is there. It has also been shared on WhatsApp group, and YouTube link where the recordings of the session is there. That has also been shared. So we have shared it on WhatsApp group right now, and I will be sharing it on mail as well. And one important announcement is there that we will be starting the session at 2 p.m. tomorrow. Since we have 3 sessions tomorrow, it's the last day of FTP. We have 3 sessions and valedictory session as well. So we will be starting at 2 p.m. tomorrow. I'll be sharing the link in the morning. Same link would be there, but I'll be reminding for the session timings. Thank you so much, participants. Have a nice day. Thank you, sir.
Okay, thank